Okay, so what have you guys done with Wireshark? Anything? Nothing? I guess I really don't know.
Use it in CyberOps.
Use it in CyberOps?
Yeah.
In what capacity?
We looked at like client-server acknowledgement messages.
Okay. Any hunting and searching, or was it more exploratory?
Yeah, for our final report, that was like one of the tools you could use to analyze the traffic that was going on at the network at the time.
Okay. So you guys at least have seen it. You know what it's about. Can install it. All that good stuff. Okay. Perfect. I'm just going to do the slideshow like this. That way, if someone chimes in, I can switch over. So instead of being full screen, I'm just going to do this. Hopefully, this will work. Okay. So traffic analysis. What traffic analysis does for us is it provides a look into our network traffic. We can use traffic analysis in Wireshark for logged or real-time monitoring. So if we fire up Wireshark right now, we can see those packets being generated in real time, right? Our screen quickly starts to fill up. We can use Wireshark for network forensics. Forensics means we're going to go and investigate something on the network. We're going to try to figure out maybe what happened, who's communicating. Maybe we're looking for a specific packet and trying to find the payload and the information inside of that packet. There's a lot that we can do in terms of that forensics work with Wireshark. And I would say that's actually probably where it's best used. Can be used to troubleshoot network issues. Personally, I have used Wireshark before to troubleshoot why DHCP wasn't working. So one time, it was actually, I think, a class lab. Student's laptop wasn't getting an IP address from the DHCP server, and so we fired up Wireshark on the PC, and we never saw a response back from the server. What we ultimately figured out, which was something we should have known right away, was that the router was blocking that broadcast message. So it can help with network issues. Anybody ever had to use it to detect any other network issues? Okay. Detect the type of traffic flowing on your network. This is another excellent example as a good use for Wireshark. So if you're a network administrator and you want to see what the heck your network is being used for, this can give you complete insight. So you can see, are people surfing the web? Are they playing games? Are they doing voice over IP? Is there a lot of broadcast traffic on my network? It can be used for intrusion detection systems, for traffic analysis in conjunction with rules to generate alerts, well, let's just say, and events. Not necessarily Wireshark in itself, but the same components that Wireshark uses is often used with intrusion detection systems. So if we take a look at network defense as a whole, depending on who you ask, this can probably change. But a lot of times network defense is broken down into intrusion detection systems, network analysis, full packet captures, seams, alerts, and event management. You could add firewalls in there. You could add a lot of different things. But the focus of what we're talking about right now is more of that traffic analysis, viewing the protocol, viewing the frames, the packets, those sorts of things. In terms of our intrusion detection systems, there is Security Onion. You guys use any of the Security Onion stuff? Snort? Okay, so you have a good idea maybe on how that looks and works. There's something similar called Suricata. We're going to get into Suricata a little bit, hopefully next week. SolarWinds has an intrusion detection system. Great, and that's a good one.
Great. Wow. I mean, other than that recent activity.
Oh yeah. Well, let's not talk about that, right? Mass chaos because of SolarWinds. And then Kismet is another one too. In terms of network analysis, there's Zeek or Bro, there's Kibana. Hope to get into a little bit of both in this class. I think I showed you guys on our NetLab environment that Zeek, there's some pre-canned Zeek labs out there. Full packet capture, there's Moloch. hopefully we'll get a chance to look at that here quick too. In terms of seams or network managers, alert and event management, there's Elasticsearch, Evebox, Splunk. The list is huge, but these are some of the more common ones. So what is Wireshark specifically? Wireshark would be a network packet protocol analyzer. So it doesn't necessarily fit in to any of these areas. Okay, maybe the network analysis, but we'll see that it has some limitations where you probably aren't going to want to analyze your entire network using Wireshark. You're better off using Wireshark for these sorts of things that we mentioned back in one of the first slides. Okay, it is cross-platform, so it can be used on Unix and Windows and Mac. I should have put that in there. It does capture live packet data from an interface. Wireshark is not an intrusion detection system, but it can help you run down potential issues or intrusions. And Wireshark does not create traffic, so keep that in mind. It does not send any packets. It's purely passive. You cannot use it to generate fake packets and things on your network. It's just passive. It's only looking. It's not modifying. It's not sending. So that's important to know too. So again, some good uses for Wireshark: troubleshooting, insight into the network, individual packet analysis, specific issues, learning. It's excellent to learn, and packet visualization. We can go into the packet and we can see all those different fields in the header, right? Source IP address, source or destination IP, source MAC, destination MAC, all that good stuff. I lost all my text. When we don't use it, when do we not want to use it? Trying to analyze the entire network when the traffic is too large. I wouldn't want to use Wireshark to try to analyze traffic from a variety of devices. By default, Wireshark is only going to look at traffic in and out of the device it's running on. So if I install Wireshark on my laptop and run it, it's only going to check for packets in and out of my laptop. I can turn it into what's called promiscuous mode, and then promiscuous mode will try to grab all the traffic that it can possibly find, even from other devices. You're going to quickly get overwhelmed, though, with information in terms of promiscuous mode. So I wouldn't want to use it to analyze, tons of traffic. It's just too much. It doesn't scale very well. So Wireshark captures all data as a frame. Frame is at the layer 2 level. It also contains layer 3 information. Contains the payload of the packet. Really, it contains anything that we would ever, I think, need to analyze traffic or do an investigation. It's not the best long-term capture tool, because what you end up having to do is you do your capture and then you have to save that and you do another capture and save that. It doesn't automatically, chunk it down into days or do log retention and that sort of thing. So it's not very well suited for that. You can import capture files from other programs, which is nice, and we'll do that in class here today. We'll take a PCAP from a different machine, and we'll open it up on our machine, and we'll be able to look into it. It can do live capture from different types of media, so Ethernet, Wi-Fi, and Bluetooth, which is nice, so you can capture traffic on a variety of types of media. In high bandwidth environments, this probably isn't a good use either. The one NIC on your laptop probably can't capture all traffic that it needs to. Intel, from what I've read, I guess, and learned, is that the Intel network cards tend to do a better job than any of the other brands in terms of capturing traffic. If it can't capture a piece of traffic, it will just drop it. It won't show up. So if your computer gets overwhelmed, if the buffer on the network card gets overwhelmed because it's trying to capture too much stuff, it's not going to tell you that. It's just not going to. It's going to kind of drop those packets. Large appliances do exist that can capture all things, because only capturing some of the data isn't good enough, right? So if you want to go and capture all things and use Wireshark, you could go out and you could buy something like this. This is a riverbed. Steel Central NetShark 4170. It's a network monitoring device. This is built specifically just to go out and capture packets. Then on those packet captures, those PCAPs, I can go and view those. There's not even a price on here anymore. But do you want to spend thousands of dollars to capture packets? Maybe you do, depending on what your situation is. But again, just your typical network card and your laptop should be fine for capturing the packets to and from that device. If you want to capture things network-wide, you would have to look into something like that.
Depending on the size of the network, but how many would you need of those for like a size that's like a BSC size?
That I do not know. That's an excellent question. I would typically probably work with a vendor or a rep to figure that out. So if I'm going to go with this riverbed, where'd my tab go? I would probably work with the CDW or this riverbed directly and say, hey, I got a network, I got 300 users. Which appliance would you recommend? And they can probably recommend. Does this actually say? Someone chimed in. I'll just flip over here in just a second. But sometimes they'll say in the specs how many users it supports. You could do that. I would venture to say that the old Linksys router would probably do better than like a Windows machine, because now it's dedicated purely to capturing packets. However, you are going to be limited with something like that too. These types of devices probably contain ASICs, which are application-specific something chips. Forgetting. But their processors essentially are designed specifically to capture packets. Whereas like a Windows network card, that's not what it's designed for, right? It's designed for us to access the network and the internet and do a variety of things. The devices and the hardware inside of something like this are designed specifically for network monitoring and packet capture. But yeah, good idea. So display filters. Display filters are going to be a big piece of what you will do as a defense analyst, or what we'll do in class, or some of the challenges. So the question is, what is a display filter? This is a filter that can limit the packets that are captured. This filter can limit the packets that are shown. This filter can limit the packets that are saved. This filter can sing karaoke, or none of the above. B, this filter can limit the packets shown. Yes. So all a display filter does is it takes your current capture and allows you to filter and hone in on something specific. Okay. To me, knowing how to work with the display filters is huge with Wireshark. It really allows you to be more efficient. Do I know a whole lot of filters? Not really. I could probably be much more efficient with Wireshark if I did and I took the time to learn it. How I typically poke around Wireshark is I'll go and Google search, how do I find X? I'll find an example of that filter and I'll bring it into my Wireshark, kind of do a copy and paste type of thing. So display filters do not limit the type of traffic that you're collecting. It doesn't limit what you're saving. It's just purely allowing you to sift through a PCAP a little bit more efficiently. And we'll do some of that here in just a minute. A capture filter, on the other hand, limits what is captured. Be careful with a capture filter, because you might be filtering out some key details of your investigation. So typically what I like to do is, if I'm going to do a capture, is I'll just capture everything, and then from there I'll use my display filters to really hone in on what I'm trying to find. Speeding up Wireshark. We talked about the possibility of potential packets and frames. I should say frames. That's the correct word. The frames being dropped. What can you do to get better performance so that you don't have drop frames? Don't use capture filters, because that adds another layer of processing. If you say I want to filter out DHCP traffic during my capture. Well, now it has to actively look at the packet to see if they're DHCP and then filter those out. So that's just more processing. Increase the buffer size. Don't do dynamic screen updates. Turn it on, close it out, or not close it out, minimize it, let it run its capture, and then come back to it later. Stop it, come back to it later. Don't resolve names. There's some options in there where you can turn off DNS name resolution. So what Wireshark will try to do is if there's a DNS request or an IP address, it will also try to resolve that to a name for you to make things better. Last step, get a better computer. You're only limited with what you got, right? With my 1985 Pinto, I'm only going to be able to drive 85. I don't care what I do to it. I'm not going to be able to go any faster. So get a better computer or look at one of those devices. Wireshark Cautions. If you're reading bug logs, you'll see security fixes. Wireshark isn't the best enterprise capture tool. Don't run as an administrator, especially when opening outside files. This last one, I think for defense analysts is a big one. A lot of times you'll get PCAPs, maybe from a sensor or maybe from a device, and now you have to open it up and you have to analyze it. Well, if there is malware in there, you could potentially trigger that, okay? So keep that in mind that you don't want to typically run those as an administrator. You should have a separate VM if you don't know what it is. So another question here, just kind of see where you guys are at. Looking at this frame capture, what is the most correct? We have an Apple computer that's requesting an HTTPS website on a remote port 61707. An Apple computer is requesting a website from 216.239.38.21. An Apple computer has an IP address of 216.239.38.21. A Congatech device is hosting a website on 172.19.131.124, or none of these are accurate. So if I take a look up at this information up in the white box, and I take a look at the Ethernet 2 frame, I can see the source is an Apple device, and it's showing me the last 6 hexadecimal digits for the MAC address. You can see how that corresponds to the full MAC address in the parentheses. I can see that the destination is a Congatech, and that could be make and manufacturer of a network card. It could possibly be a PC. So I know for sure that the source is an Apple computer. What is that Apple computer doing?
Yeah, I'd say B.
I would say you're right. So we got an Apple computer. It has a source IP address of 172.19.131.124. It's going out to 216.239.38.21. And the source port is 61.707. Destination port, port 80. Port 80 is HTTP, right? So more than likely it's requesting a website. And that website, again, is on the destination IP address, 216.239.38.21. Questions? Okay, so if you do not have Wireshark installed on your computer, I'd like you to go out there and do that. If you do, you can go ahead and open it up. Give a quick little crash course here, and then we'll analyze some traffic. So I am on version 3.4.2. You don't have to have the latest version to do what we're going to do today. But typically, you want to have the latest version. And when you get to Wireshark, this is typically what you see, depending on your preferences that you chose. But I have all my recent files that I've taken a look at, and then I have my capture area. Here's where I can enter in a capture filter. So if I want to hone in just on DHCP traffic, I can do a capture filter. We just talked about maybe not doing that because it slows down performance. Depending on your situation, maybe you'll be fine, but usually you will probably capture all your traffic and then use display filters. Then below that, you'll find all of your interfaces that Wireshark picks up that it can capture traffic from. Okay? During the install process, you probably noticed something about USB capture too, and you could actually capture information from a USB device if you wanted. The cool thing here is it shows you if that interface is actually getting traffic through it, so you know which one to select. So if you're like me, and you got a bunch of VM stuff installed, I have a huge list of interfaces, okay? And so I want to choose my Ethernet because I'm connected to Ethernet. And so when I select my Ethernet, I can either double click on it and it will start, or I can come up to my shark fin and that can start capturing packets. And you can see that my packets are going to just start to populate, okay? Right now, this is going to capture information going in and out of my interface, my Ethernet interface. I'm going to go ahead and I'm going to stop it with the red box here. And just again, to give you a quick crash course here before we see what we can figure out, is it breaks it down into the number. So first frame it captured, second frame it captured, third frame it captured, labels all of those. It puts a timestamp on it. You see the source and destination IP address. I think I have the default view, but you can change all these if you want. So if I don't want to see the source IP address, I can get rid of those columns, and I believe that's in view, right? Somewhere in here. If you guys find it, let me know. But you can edit all these columns that you want. I typically, what's that?
You can just right-click the filter column, and there's
there we go.
check marks.
There we go. Thank you. So I can just right-click up here, and I can move these around. I can pick which ones I want. So we got source, destination. We got the protocol. We got the length, the size, and then any information that it can display to you here in readable text. If you click on any of these columns, it will sort by those columns. And then if I select an individual packet, I get the individual packet's information down here. And then I also get the raw data and the ASCII equivalent of that raw data. So sometimes on here you can pick out readable information. So this could be a tool that an attacker might use, maybe to pick up a password that's sent in plain text, credit card number that's sent in plain text, those sorts of things. They can come in here and they can view, with not a whole lot of effort, in plain text, what was going on with that packet. Okay. Any questions with, I guess, the main view and window of Wireshark? Okay, well, what ends up typically happening is you get just a ton of traffic. If I let this run even for 10 minutes, I'm going to get thousands and thousands and thousands of frames. So this is where your display filters come into play. Your display filters to me are your best tool to go and try to figure out exactly what you're looking for. There are a ton of display filters that you can use. I would say probably the most widely used, at least for myself, would be the IP.address. So it's IP.ADDR. And then if you're looking for a specific IP address, you do an equal equal. So for your expression here, is that what that's called? Your expression, you can do equals equals. You could do not equals. You could do less than. You could do greater than. You could do less than or equal to, greater than or equal to. Oops. You do all those sorts of things. But let me just do IP address. Equals equals 165.234.48.171. And if you got a good filter, it's going to turn to green. And now it's going to filter out all traffic either from the source or the destination that has 165.234.48.171 in it. So I can see that here it's showing up on the destination side, here it's showing up in the source side. Okay, for me, this is where I spend a lot of time Googling to figure out what exact filter I want to use. And one thing that you can do is right to the left of the filter, you can save these. So that's nice. You can also see recently used filters as well. Another option that you have where's my expression box? It went away because my resolution is different. Where's my expression box? Here we go. Under Analyze, right in front of my face, we have Display Filter Expression, and you might have a little box right to the right of your display filter line. What this does is this kind of gives you a listing of all the possible items that you can select for filters. So we got 802.11 traffic, that's wireless traffic, right? What's probably most common to us would be like IP traffic, I'm going to assume. But you can see all the different things that you can filter on. There's some DOCSIS information in there even. That'd be information going to your cable modem. So where's IP? Okay, here's like IP address, and then we have is present, equal, equal, not equal. Here's IPv4. What are all the different options under IPv4? Well, IP address, IP bogus version, IP checksum. So you got all these things that you can filter on based on IP. IP source host, IP source address. So if I want to do IP source address is equal to 165.234.48.171, what it does is it creates that display filter for you. So if you know the display filter, you can just type it right in there. If you want to use that expression, you can go build a query using that dialog box. So that might help you as well. Questions, comments, pointers, anything on that? Okay, let's take a look here at a PCAP that I have. So if you go back to the class shell, under traffic analysis, I have this Wireshark 1 assignment. We'll do this together in class. There's a Word doc. And then there is the Wireshark assignment 1.pcap. Okay, so overview says in this lab, you'll use Wireshark to search through a traffic capture and derive conclusions about the packets that are captured. A PCAP file is attached to the class shell that contains the specific traffic capture for the lab. You can verify that you have the correct file by going to the statistics, capture file properties, and verify that there are 16,133 packets captured. Answer the following questions with both the answer and a screenshot showing your search and how you got the results. Okay? This is the exact assignment that I got in week 10 for my master's class for intrusion detection. I stole this from DSU, just to give you guys an idea of some of the stuff that I went through. This is master's level stuff. You guys can do it, no problem. Probably better than I could. So let's dive in. There's a packet capture. It's called Wireshark Assignment 1, PCAP. You can download it. Once it's downloaded, if you have Wireshark installed, you can just click on it and it will open it up in Wireshark. Okay? So one of the first things that it wants us to do is to verify there's 16,133 packets. A couple different ways to do that. The instructions say to go to the statistics. I just scrolled all the way to the bottom. I see there's 16,133, right? Anybody having trouble opening or getting to this? Okay, let's take a look at this first one. So it says, what is the IP address of the client in the capture? What is the IP address of the client in the capture? Yeah.
192.168.19.225.
192.168.19.225. How did you come up with that?
I found a client hello coming from 192.168.19.225 to 52.40.13.190. If you look up TLS version 1.2, you can find this information.
Okay. So there's going to be a few different ways you could probably figure this out. So what Richard said, let me go backwards now, is he was looking for a client hello. So client hello messages are going to tell us who the client is, right? And you said you found that in the TLS information?
Yes.
Was there a specific filter or anything that you used?
I just filtered by protocol, and then I found the hello.
You know the number of it by chance?
Packet 31
Packet 31. Way too far down.
or 26.
31 or 26. Oh, not by number anymore. We can do that. So he found this packet right here, the client hello, 192.168.19.225. Anybody else find any other way to do this? Is that just something that you knew, or was it something you looked up?
That I had an idea from the CyberOps class, but I did look up, and that should indicate that there's a client-server relationship.
Okay, excellent. And Megan said she just did a Control F and hello.
You can also just like the very first packets using DNS, and it tells you which IP address is making the query.
This one right here.
Yeah.
So I got to be honest with you, this is what I did, right? what you guys are doing with the client hello is probably much better because you know for sure. But I remember when I did this assignment, I looked at these kind of first DNS packets and I said, okay, well, if 192.168.19.225 is making the query, that's the client. The response would come back from the server, right? So there's a variety of ways to do this. There's not, one specific way typically. There might be for certain things, but I think for this, there's going to be a variety of ways. So going back to the assignment, what is the, go ahead.
I'll see the Skype one that you have.
Really? What's
Yeah.
your packet one then?
It's a,
UDP?
yep.
A UDP? Oh, I think I know why. Because at some point on my machine,
You enable the certain.
I enabled a certain option. And so let me ask you this. What is your first number of your packet? Is it 1 or is it 0?
One.
And what's the time? Is it this
Same.
first one?
Same time, and
Okay.
the next time is the same.
I have some option in here. I can't remember where it's at, where I probably have a few more things than you guys do.
It's the same length, too, 86. My UDP is 86 for length.
Might be under protocol of UDP.
Where's that at?
It's in preferences. You go to edit preferences, then it'll be under protocols. If you scroll down to UDP, I think you have
Yeah.
check it.
Somewhere, somehow, I must have enabled that. Maybe it was during the install process even, I don't know. Well, I guess I'm not 100% sure. Is Skype actually a listed protocol? I don't really see anything under UDP here. I do have Skype listed. Well, let's not worry about it. I don't have a good answer for you. I don't know if what option I would have selected, but I know I had tweaked a few things at some point. Okay, so anyways, going back to the assignment here, what is the IP address of the client in the capture? 192.168. Was it 1.225 we said?
19.
Or 19.225, thank you. And then so for these, I want you to show the answer and a screenshot showing your search or how you got the results. And so I'm just going to do this. Take a quick screenshot. And if you use the display filter or something, that's fine. If you use Control F, that's fine. Just document that. I looked for the DNS query. I looked at the DNS query and saw that. Maybe, I think it was Megan said, I did, so she might write something like this. Did a Control F and looked for client hello. Maybe you want to do an actual filter, right? So what would that filter be? Does anybody know? Did you use a filter? You said you just went and looked, right? So I might do something like this: Wireshark filter for client hello. So maybe I'm looking for this, and I can go and I can see if this gives me anything. It was TLS though you found, right? Not SSL. We'll see what this does. There's a client hello. So that worked. Found all these client hellos, 26, 66, 70. And so maybe you use that. Okay? Google's our friend, especially in this class. Or I could probably bust out the Wireshark manual. Some good reading for you. Okay, let's go to the next one. What is the operating system of the client in the capture? The operating system of the client in the capture.
Microsoft Windows.
Microsoft Windows. Okay, so how did you find that?
I used the filter IP.dst = 192.168.19.225 ampersand HTTP, and I looked for an OSCP packet. I know that a frame that is within 65,535 bytes or below usually comes from a Microsoft Windows machine.
Okay, so what is after the ampersand?
Oh, and HTTP.
This is what Richard did.
As soon as that comes up, I found an OCSP packet,
Okay.
and then I double-clicked on that. And then I went to, it's under Transmission Control Protocol. And then if you scroll down a little bit, there'll be a window size underneath flags.
64,240.
Now, within that size, that determines that it's not Mac OS, because Mac OS starts at 80,000 bytes. So it's within the framework for Microsoft Windows, along with the, I believe if you go under, there's more information related to the MAC address comes from a VMware station, and then there is a host name as well that is win-femjc866, which is consistent with the Microsoft Windows machine.
Okay, so for Richard, he found, I'm guessing this is based on your research, he found that certain window sizes can kind of give you an idea if it's Windows or a different operating system. Also, then within the information within the frame, you had said that, what was the other thing that you had said?
I had found that, I found that the MAC address was.
Oh, the MAC address, and then the Windows name, thank you, the host name. So those are definitely good indicators, right? So you could use that display filter, take a screenshot of that, kind of explain, this is how I came about this. Did anybody else find any other way?
You just click on an HTTP packet.
On any HTTP packet?
Yeah.
I'm going to get rid of this filter here. I know there's one sitting right there, but I just want to get rid of this filter. Find an HTTP packet. Okay.
And then down on the bottom pane.
Bottom pane, I'm just going to double click on and make this big
There
here.
you go. It says right there, Windows. You're using Mozilla.
Windows NT 6.3.
That may be
That's definitely a good option. Now, we're pretending we're not trying to investigate a hacker here, but if we were trying to investigate a hacker, what's the issue with trying to do this? You can spoof this. Okay, so just keep that in mind. When I did this assignment, this is what I did. But our instructor kind of told us beforehand, we're not really investigating a hacker or a red teamer. Richard's method would be a little bit more concrete because there's multiple things to base his evidence around. We got the frame size, we got the Windows name, you had the MAC address. This is we just see the Windows NT 6.3. So that's an option as well. Again, if you have no clue, what are you going to do? Well, this is what I'm going to do. How can I figure out the OS used in Wireshark? And maybe I start searching around and see what people have to say. It says try to find an HTTP request if you can. Those usually have the OS information field in their headers. Zilla 4.0, compatibility, and it kind of gives you some idea. Windows XP machine would be 5.1. Windows XP 5.1. 5.0 is Windows 2000. 6.0 is Vista. 6.1 is Windows 7. Okay, so what is the operating system? Well, we know it's Windows, right? We figured that out. Well, what is NT 6.3?
It's 7, right? You can say.
Let's just do a quick search.
Well, it could be a couple different things.
It's WoW 64.
It was WoW 64? I'm just going to look up this here real quick. Wikipedia
Yeah,
is
it says
always
it
basically
could be Windows 8.1 or Windows Server 2012 R2.
Okay. 6.3 could be 8.1. There's Server 2012 R2. Now, is there a way in which we can go and get more definitive? So I know it's 8.1 or 2012 R2. You know, Richard had said that it had a name of Win- whatever. That's a default name that's given to a Windows client that gets put on the network, so I would lean towards 8.1. I'm hoping that servers don't just have random names. So that's a little bit more evidence. That's not necessarily the case, but you know, that could be some more evidence. Maybe so I want to do some more research further. How to tell if machine is 8.1 or server. I'm not going to spend a ton of time searching here, but maybe you could find something that would give some indication on whether it's a server machine or a client machine. In the interest of time here, I'm just going to say it's Windows 8.1. Okay, maybe you use this filter like Richard did, so you take a snapshot of that. Paste that in there. Or maybe you do, like Matt had said, and you just search for HTTP, find an HTTP request.
You can actually scroll down this center pane a little bit.
Okay.
And under hypertext transfer protocol, or maybe not scroll down. Yeah, right there. I'll move it.
Screenshot of that.
Yeah, and if you Google that right there, Windows NT 6.3, WoW 64, RB50,
Okay.
it actually comes up with you're running Firefox 52 on Windows 8.1.
Nice. Okay, so Matt found this within the HTTP. He Google searched this, got some more information. So there's a variety of ways to do it. The bottom line, whether you did it Richard's way, my way, Matt's way, whosever way, you had to do some research, right? But it's out there, you can find it. And so that's all I'm looking for, even when we do like those nice challenges. See if you can figure it out. And what did you use? What resources? So maybe you want to go and take a snapshot or a snippet of that. And then so there's the filter I used. Just going to highlight this. You know, however you did it. And so I paste that in that document, and I say, I use the filter above, and then further researched the value under user agent. And so if you're someone like me who uses this once in a blue moon, you know, Google's going to be your friend, and you'll probably just do individual searches and queries, and you probably won't, you know, save those filters. But if you're a cyber defense analyst and you do this day in, day out, you'll probably start to develop your own filters and your own methodologies, and you'll save those, and you know, you'll just get better. You'll get better with time. It's all practice, especially in the cyber defense world. You know, the more that you do cyber offensive security too, the more that you work with things and do things, you're just going to get better at it. And so people are going to be at all different levels and comfort with the tools and things that we're going to use. Just keep that in mind. So what is the username and password to the FTP server? So there's some FTP traffic here. And so let me just ask you this. If I'm looking for FTP traffic, what would be a good filter to throw in there right away?
FTP.
FTP, right? Yep. No clue what you're looking for other than it's FTP. So I'm just going to do a quick filter on FTP. And then I can start to scroll through this. Now, what you might find in a large environment, this is why Wireshark isn't the best, is you get overwhelmed with FTP traffic, right? Now you got 10,000 packets to sift through. Luckily, we don't have that case in this scenario, so there's probably better filters to find user and password. Is anybody able to find a more specific filter? Yeah.
TCP dot stream space EQ space 163. Yep. Now, what that brings up, and then what I did past this is it, like, say, if you right-click on any one of those packets with FTP and you go to follow, and then go follow TCP stream, this should bring up the entire conversation.
Nice. Hoping that someone would mention following the stream, especially with FTP. So one of the nice things with Wireshark, right, is we tend to get, like I said, a bunch of packets, but a lot of those packets follow a communication channel between a couple of devices. And so what you can do is when you find a packet, you can right-click on it, and you can choose follow stream. It's going to go and find all the packets relating to that session and put them kind of in a nice readable format. Now, the way I have mine displayed right here is to show it in ASCII, but sometimes you might get it like in the raw data format. I mean, sometimes that's maybe what you want, depending on what you're doing. So keep in mind that you do have the ability to change how this is displayed. And so I guess I don't know what's the significance of the equal 163. That's the stream number.
Now, that should be, if I remember correctly, I believe that's destination port and source port multiplied.
Okay. And that's just an indicator of
Yeah, it's just an indicator of that specific traffic.
Okay. Cool. Going back, just doing a quick simple search for FTP, I could do the same thing. Here's my first FTP packet. I could right-click, follow TCP stream, and I'm going to start to get some information. Sam?
I'm going to say there is another, if you want to see all login attempts, you can do the filter ftp.request.command == user.
Say that one more time.
ftp.request.command.
Okay.
And then that's going to be == and then user all capital letters.
A variety of ways to do this. Like I mentioned before, display filters are your key. If you can get something real fine-grained, like these guys mentioned, awesome. If you're more like me and you got to kind of hunt and poke your way around, that's fine too. As long as you can figure it out at this point. We're just trying to get us used to using Wireshark. And so what was the question on the thing? What is the username and password for the FTP server? So what do we find?
Admin for username and goats_123.
Goats. Okay, here's the username admin, password, goats_123. Going back, admin. Username is admin, password is _123. And then how did you figure that out?
That was through following the TCP stream of the conversation showing that a username of admin was entered, it was received, it was accepted and received, and then a request for password was sent back, the password was entered, and then a success was responded.
Okay. So follow TCP stream of the FTP data. I'm going to say extracted from there. And so that was the filter that Richard used. I'm going to use the filter that Sam used. What was that again? There it is. Maybe I'll open this up. Again, whatever you did, document it. I'm just trying to grab a variety of ways here. And so that's my filter that I used. That. Okay. Real quick, going back to the follow stream, and I apologize if you guys know this already, but maybe some people don't. So like, I'm just going to go to HTTP here. So I got some HTTP messages going between my client at 19.255 to the destination at 237 here. I can go to right click on that packet and I can follow either the TCP stream or the HTTP stream if I want. So I'm going to just follow the HTTP stream. And then what it does is it goes and grabs all the packets for that communication channel. So it creates a display filter for me. The display filter it created for me was TCP stream equals 0. And then here's all the packets for that communication channel for HTTP between the 19.255 and that server. And then I'm viewing it right now in ASCII, so I'm trying to view as much plain text information as I can. But if this was something like HTTPS, right, or if it's encrypted using TLS or SSL, I'm not gonna get this. And I can see here, it looks like they went to this website, .cloudfront.net. Okay, 4. This one might be a little more difficult, but it says take a screenshot of one of the JPEG files that were transferred over FTP. It says take a screenshot of the actual image, not just the packets. So a couple different things going on here. We know it's FTP. We know there was a file that was transferred between the client and the FTP server. What we actually want to try to do is see if we can see that actual file or possibly even extract that file out of Packet Tracer. Yes.
So what I did for this particular one, it's going to be dealing with the raw data like you just showed.
Okay.
I've used the filter of IP.addr equals 192.168.19.225.
Okay.
Ampersand TCP port equals 62337. An explanation of the 62337 is if you multiply port 243 by 256 and you add 129 to it, you get 62,337. So that's how we're getting to that.
Okay, but how did you know that?
Research.
Okay, research.
See 62337 IP address 19. Oh, you have 255.
Oh, thank you. 55, right? Yep.
Okay, now that brings up some FTP data, and what I did from here is I right-clicked and I followed the TCP stream
Okay.
to get the entire conversation. And then what I did from this point, if you go to show data as raw.
So right now, he's telling me to go to show data as raw, but this is a picture file being transferred, right? So there's not really any readable data. So go to raw.
Then what I did at this point is if you go to the very bottom, you can see a Save As button. You'll have to save that as, I believe it is .jpg, and you'll be able to view the contents of that file.
Type it, name it extract.jpg. Save that. And where the heck did it go? Here it is. Open it up, and it's a cat in a computer. Okay. Excellent. I believe this is how I went about it. I searched for FTP. Okay. And what I was looking for is for a request of a file. It tells us that it's a JPG, right? But what if you didn't know? So we got FTP traffic, but I don't know what type of file was downloaded or requested. So I have to probably figure that out too, right? And there's probably a better way to filter for this, and I think I probably did find a better way. But anyways, I'm going to go and kind of search through here to figure out exactly which type of file. And here I can see the request that I'm looking for a .jpg. Okay? And so what I might do here is I might try to follow this, and I don't know what I'm going to get, but I might try to follow this stream. And I can see that I'm opening the data channel for file upload to the server for the cat inside of the computer.jpg that was successfully transferred. So I know now that that was what was transferred, right? And then from there, I think I did a Google search on how do I extract FTP file from Wireshark. I think I found a post, something like this. This gets to what Richard was just showing and explaining about finding the FTP data. And then based on that FTP data, extracting it in its raw format and giving it an extension. Okay. So I think that's the way, if I remember correctly, how I went about it. First, I figured out that it was a JPEG. I think I tweaked this a little bit, but for the most part, it's exactly what I did. I don't think he told us what type of file it was. But I figured out the file type, then had to go find the FTP data, extract it, save it as a JPG because that's what I knew it was then, and then I could open it up. Any other way, maybe that you guys found here in your research that might work? There is an option, I think. Let's see if I can find it. If you go to File and Export Objects, under Export Objects, sometimes there is ways that you can export sometimes there are ways in which you can export things that it can find inside of the capture. So if it finds that files or things have been transferred through HTTP, I believe that will also work.
Yeah, I use that for CyberOps. If you do extract HTTP, you can actually download the malicious files that were downloaded in that Wireshark capture.
Okay. Yes, I've used it for that too. So that's an avenue as well. So the question is, how did you get into the save part where it shows the packet in more detail? I missed that. Yeah, you right click and follow that stream. So this is what we ultimately did is you ultimately need to find the FTP data, because that's the actual raw data that's being transferred. And then you can, once you find the FTP data, you can follow the stream. And then you can convert it to, or display it in raw. And then you save as. Another option here might also be to decode. Does that work? Yeah, no. I think there's one other option where you can do it right within Wireshark. Got it? Okay, so I'm supposed to take a screenshot for this one of the actual picture. Dang, we're almost out of time on. Okay, the next one, there was an error browsing a particular website. What was the URL and the error? Okay, so again, if you have no clue, I'd probably Google search. How do I find URLs or errors that clients have gone to? There's my Wireshark. Did I close it? Oh. Close the PCAP. Okay, so if you're going to try to access a URL, what type of traffic is that going to be?
HTTP.
HTTP or HTTPS, right? So what I might do is I might go look specifically for HTTP, and I could do something like, oh, I could just scroll through this, right? And I would look for my GET requests, and I would see if I get a successful response back from my GET requests. That could be a manual, probably painstaking option. Another option would be to go and specifically look for the different HTTP error messages, like a 505 or a 301 or 401. Here's a 301. But this has been permanently moved. So there's some filters you could do that way. Did anybody find a different way?
That's the method that I used. I just looked for the 301. I found
Okay.
Created a very specific filter. I guess it's going to be, I'll put it in the chat for you to.
Big one? Okay.
Throw it in the chat.
Yes, the one I found one, but it only works if you get a certain
message.
HTTP response code.
So what I did is I looked for the source port being HTTP. I looked for the response of 301, which is being error or moved permanently, and then I ampersand the location to HTTP. There was an HTTPS request that also failed, but that's not the case of the dsu.edu question.
Okay. So you could probably get away with these first two, maybe, right? and
It probably should.
it would show you the HTTP and HTTPS. I'm not getting that first. There it is. Let me just try that once. Came up with that one. And if you said if I add the other one, we'll also show the HTTPS one.
It should. Well, I guess that'd be a different code because I think it'd be 307. Because we're looking for 301.
Yeah.
So I think is that the? I thought it was that the dsu.edu was moved or moved.
Oh, that's what you're supposed to find. So that, just to break this down a little bit here, specifically looking for port 80, like you said, because that's HTTP, and I just asked, what protocol we use, and that's HTTP. And he's looking for this particular code. I think the way that I did it, I think I just used this. And then I also did a Google search on HTTP error codes. And I searched for those errors as well. Anything I could find. So I did like a search for a 301, I did a search for a 500, I did a search for all these different error codes to see if I could find anything. And ultimately, you would end up finding the 301, and you find this error code, and that the site was permanently moved.
There's also 404 not found.
There's also a 404. Okay. There is a couple 404s. There's another issue or error. And again, like I said, I just went through and any error code response number that I could find, I threw it in there to see if I could find any of the issues. And I think I documented all of those.